Hi, good afternoon. Thanks for joining again. I'm very excited about this quick lesson because there's something that I've been trying to figure out with Cameo for quite a while now, and I actually reached out to Salius Pavakis, who runs the MBSE execution channel. He actually had a solution for this, which I think a lot of people may not understand how to implement, and it's a really neat thing that you can do, and that's with invariants of lifelines in order to pass test verdicts or verdict kinds back to a test case. So what you're looking at here is an entire test scenario based on having a domain block that has a value property named test result typed by verdict kind. And if you look, there is an interaction that is actually an interaction of the domain that involves the user and the system. The user will send a turn on signal to this system, and then the system will check that the temperature is greater than 20. So that is the invariant in this case. That is what Cameo will actually look at, the value property of the system and what its runtime value is. And if it is less than 20, this test case will produce a result or a verdict of fail, which is very neat. A lot of times it seems as though Cameo will only allow you to use state invariants. So if you notice in your interaction, you have the state invariant, and what you can do is click on that. And if there is a state machine for this part of your system, you'll see a list of states. However, you can also simply select cancel. And in that case, you simply get this invariant that shows up with an empty curly braces expression. And what you can do is enter in some type of an expression that will be evaluated. So let's get right into it and actually run this simulation. What will happen is we will run this simulation from the domain level, but there's an activity that calls the behavior of this interaction. Notice we have test case as a stereotype of the call behavior action. That stereotype was actually applied to the interaction. So notice we have domain, and when you stereotype that as a test case, what happens is there is then a return that is typed by a return named verdict typed by the verdict kind enumeration, and that will show up with a call behavior action if you were to drag that interaction onto the call behavior action. So we actually orchestrate this test from the activity at the domain level. It will call the behavior of this interaction, send this signal. This system will actually be running this activity, listening for that signal, and then the temperature value property will be checked that it is greater than 20. And if it is not greater than 20, we should return that verdict of fail. So let's run the simulation and watch what happens. That was a little bit fast, so let's slow that down a little bit. So the activity diagram starts, this call behavior action calls the interaction, sends the signal, the temperature is checked, and then we fail because the actual temperature is actually only 10. So in this case, we can then try some other value that will be the runtime value for this value property, or we could change the expression. Now when we rerun this simulation, it should check that, and we should receive a verdict of pass. And there we have it. So we received the verdict of pass, and I think that is a very neat thing that you can do with invariants and for performing test cases, because a lot of times you'll be wanting to check other things, not simply whether things are in a specific state, but whether or not there are specific values that are met or at certain levels depending on what you would like them to be. So that could be what your test is, that the temperature is greater than 20, and when that completes, it'll output that verdict, and you can pass that verdict anywhere you'd like. In this case, we simply passed it to this other opaque action that then assigned it to a value property called test result, which was a value property of the domain, because that is what's executing this activity. So let's say we did have a state machine. Salius actually does have other videos on model-based testing that you can look at for more complex scenarios that involve test cases with state invariants. But for the sake of demonstration, what we could do is add a quick state machine in here just to see what that looks like if you had state invariants. So let's create a diagram, and then we'll go to a state machine diagram, and we will have a simple off and on state. And then what we could do is use a change event that says after 5 seconds it should transition to on, and then that will actually wait that amount of time, then transition. And your state invariant could involve a duration constraint, or we could simply create a signal here. So we can drag that signal in that we've already created called turn on, and then we'll pass back to the off state. We use a turn off state or state transition. So then what we can do in this interaction is use a state invariant, and notice we now have the list of states that we would like to check that it is in after the system receives the turn on signal. So we would say on, and then if it is in fact on after that signal is sent, that would be checked and the results would be returned. So let's run that simulation quickly and see what that looks like. So what we can do is go to the system and see what the classifier behavior is. If you notice, I think as of right now, the system's classifier behavior is this activity. So what we can do is actually simply delete this activity, or you can unspecify that. But then what we can do is make sure that the classifier behavior is this state machine. So we set it to the state machine, and that should automatically start up when we run the simulation. And we can view that here. So we have 2 state machines running currently. So let's run this again from the domain level. And we received a test result of pass because the system was in fact in the on state. If we were to change this to a different state, that should in fact fail. So let's change that to the off state and see what happens. Now that that's set to off, this should theoretically fail if the system is not in the off state. And we received a fail because the invariant was not met. And that is a quick demonstration of how you can use test case stereotype on an interaction to actually return results and check for specific states, but also other types of invariants such as value properties to make sure that those values are being met or those constraints are being met for specific value properties. The other thing that you can do with this is add in the duration constraints. So if you were to have a duration constraint here that said 1s, then this would also check that the system is in this specific state after receiving that signal within 1 second. So we can change this back to the on state, which would pass, but then let's go back to the state machine and put in a time event for the transition instead of that turn on signal. So we will use a simple change event and type in after 2s, which will cause it to take longer than we have specified with the duration constraint. And then notice this should wait 2 seconds before transitioning. And it looks like we received a pass, but that was because this behavior actually started before that signal was actually sent. So what we could do in that case would be to use an operation call, and what we could do is create an element for this block that is an operation. That would be to start the state machine, for instance. And then that operation could have a method, and that method could be the state machine for the system. So let's grab that and just insert that as the operation. We'll add that operation call here, and then a duration constraint from the time we call that operation to when it is actually in its on state. And we'll say that should be 1 second, and it should take longer than 1 second for that to happen. So in this case, we are hoping that it fails. And if you notice, the state machine started automatically, and that's because of the classifier behavior issue. So if we go to the system block, check the classifier behavior, we actually don't want to have that, so we unspecify that so that it doesn't start up automatically. And then notice it's not starting automatically. It only will start when that operation is called. And because this is set to being synchronous, if you notice, we got stuck right there. So we can change this to an asynchronous message call, and then that should continue along. And we received the results of fail because it took 2 seconds to reach the on state rather than that 1 second. So that is another type of invariant that you can implement in a test case, and that has to do with whether or not states are in the specified states within specific amounts of times that you set with those duration constraints. The other checks that you can have obviously are simply those state invariants. But then this really, really neat one that I think you guys will like a lot is how you can actually use value properties and check that they are within specific ranges, or you could have other more complex constraints here to define what that invariant should be. But then going back to how you do that, you go with the state invariant, put it on the lifeline, and then instead of selecting one of these states, you simply select cancel, and then you have the option there, and then you're working with the value properties that belong to the block that types these lifelines. If you have any questions on that, please feel free to reach out. Also, if you're interested in Cameo licensing, you can reach out to us at STC, and we're happy to help you with that. We also have a team of over 80 MBSE experts who are happy to help your organization. If you're just getting into MBSE, or if you've been doing it for a while and you need some assistance on projects, let us know, and we are happy to help. Thanks.